Periodic properties of alkali metals. See, on moving down the group, the size of the metal increases because of the addition of a valence shell increases down the group, and thereby the atomic and ionic radius increases down the group. The first group elements forms monovalent ions. These monovalent ions are smaller than the respective parent atom as expected. Regarding ionization enthalpy, alkali metals have lowest ionization enthalpy compared to other elements present in the respective period. As we go down the group, the ionization enthalpy decreases due to increase in the atomic size. In addition to, the number of inner cells also increases. Why these elements exhibit decrease in ionization energy? Because of the increase in the size of the ions. The next property is solvation enthalpy or hydration enthalpy. What is solvation enthalpy or hydration energy? The amount of energy released or absorbed when 1 mole of an ion is dissolved in a large amount of water. Lithium salts are more soluble than the salts of other metals of group 1. For example, lithium chlorate is up to 12 times more soluble than sodium chlorate. Other salts like potassium chlorate, rubidium chlorate and cesium chlorates have solubility only 10 to the power 3 times of that of lithium chlorate. The high solubility of lithium salt is due to strong solvation of small size of lithium atom or ion. See, you could see in this module, the size of the ions increases and thereby the solvation enthalpy decreases as we move down the group. Next, how can we test the presence of alkali metal in a particular sample? That is flame test. When alkali metal salts are moist with concentrated hydrochloric acid and are heated on a platinum wire in the flame, they show characteristic color. Why these characteristic colors are imparted to the flame, See, the metallic salt, as they are in the ground state, they have some amount of energy. When it is heated, the electrons are excited from ground state to higher energy level, that is the excited state, and it absorbs the visible light in the specific region so that they impart color to flame. Look at this flame of lithium salt in Bunsen flame. It imparts a candy apple red color. Next, sodium impart yellow color to the flame. Potassium impart a purple or lilac color to the flame. Some of the chemical properties of alkali metal. First, reaction with the oxygen. You can see the reaction of alkali metal with the oxygen. When the alkali metals are on exposure to air or oxygen, it burns vigorously and forms oxide on their surface. Look at here, lithium forms only one oxide, that is the mono oxide only. So lithium plus oxygen gives lithium oxide. The next one is sodium reacts with oxygen to form sodium peroxide. Na2O2 is what? Sodium peroxide. Likewise, the other metals all form superoxides. The general formula is given in this module. Metal plus oxygen gives metal superoxide. MO2 is a formula for superoxide. When this alkali metal oxides are dissolved in water, it gives their respective hydroxide. For example, lithium reacts with water to give lithium hydroxide. Students, here they have given the image of potassium superoxide and cesium superoxide. When these metals are exposed to oxygen, it gives their respective superoxides. And the oxidation number of each elements and their oxide compounds is also given. Lithium oxide, here lithium's oxidation is +1 and the oxygen is -2. That's why lithium Li2O is the formula for lithium oxide. Next, sodium peroxide. Sodium's oxidation number is +1. Oxygen's oxidation number is -1. So sodium peroxide is Na2O2. Rubidium superoxide. Here rubidium's oxidation number is +1. Oxygen's oxidation number is -1/2. So the formula for rubidium superoxide is RbO2. See, I told you when a metallic oxide reacts with water, it gives its respective hydroxides only. But when alkali metals reacts with water, it gives their hydroxides and also it releases hydrogen gas. So look at this equation. Sodium reacts with water to give sodium hydroxide and hydrogen gas. Then reaction with the hydrogen. When lithium reacts with the hydrogen to give their respective hydride, lithium hydride. So lithium plus 1 moles of hydrogen gives lithium hydride. The formula is LiH, 2 molecules. The reaction with the halides. The alkali metals reacts with the halogen to form the halides. This reaction is a vigorous reaction. You could see the vigorous reaction, nature of this reaction in this module. Okay, so this reactivity towards halogen decreases along the group. Why? Because the ionization enthalpy decreases down the group. That's why the reactivity towards halogen decreases. One more thing I want to stress here is lithium iodide shows covalent character. Lithium ion is smallest cation. So the polarizing power of iodide is high. Because of these two characteristics, lithium iodide is covalent in nature. So these alkali metals, halides are crystalline solids. They are they have high melting point and they are soluble in water. They have large negative enthalpies of formation and they are very stable compounds. Look at the module, the sodium chloride formation. Here sodium forms a monovalent ion, cation, and it oxidized and forms monovalent ion. At the same time, this chlorine molecule, gains 1 electron and it reduces and forms a monovalent anion. Okay, this reaction is a vigorous reaction. Then the next property is reaction of alkali metals with ammonia. See, when this alkali metals reacts with liquid ammonia, it gives deep blue color. You can look at this module, the color of the solution becomes blue, and also this solution is conducting in nature. The conductivity is similar to the conductivity of the metals. For example, the specific conductivity of mercury is 10 to the power 4 per ohm. Same way, the conductivity of sodium in liquid ammonia is how much, 0.5 into 10 to the power 4 per ohm. Why this happens in the ammonia? Because the alkali metals readily loses, the atoms of alkali metal readily loses its valence electron in ammonia solution and forms a cation and the electron, that is ammoniated cation and ammoniated electrons are found. The blue color of the solution is due to the ammoniated electron which absorbs the energy in the visible region of light and thus imparts blue color to the solution. The solution is paramagnetic. See, you could see in the module, on long standing the alkali metal with the ammonia, it releases hydrogen gas and forms brown color amine, metallic amine.